My name is Amal, Jina, Senior Energy Engineer for Decarbonization and Business Development at Simcoe Sustainable Thermal Solutions. So my topic for today is going to be district energy. And district energy is more than piping infrastructure. It is the backbone that enables sustainable cities. Next slide, please. In case you're changing the slide. Okay, this is the agenda for today.
You're controlling the slides.
Okay, this is the agenda for today. I'm going to go over the introduction and background briefly, and then I'll dive into district heating and cooling, where I'll cover the advantages and benefits, its evolution, the challenges, and whether it makes financial sense. So this is our background. We were established in 1913, and in 1967, the Canadian Ice Machine Company was renamed Simcoe. In 1969, we were purchased by Toromont Industries, and we expanded into the USA in 1972. In 2022, we opened a new head office in Burlington, and today we have 1,200 plus employees located throughout North America, 22 offices located throughout North America, 550 certified mechanics and technicians, and 1,500 plus active service contracts. So yes, we've been doing refrigeration since 1913, and we're keeping things cool before even air conditioning was cool. Now, what do we provide? We provide thermal management solutions. And what is that? That's the heating and cooling needs, and we use clean energy sources. What do? We do design and build. We provide engineering services. We can provide manufacturing, installation, commissioning, service and maintenance, plant operation, and part sourcing. We do everything that you see on here. And we also do decarbonization. So please contact us if you need any of these done. So why is natural refrigerant heat pumps on this slide? It's because we use primarily natural refrigerant heat pumps as the main tool used for district energy. And why is that? Because Michael Pathak just mentioned it's clean energy provided, it uses a fraction of electricity, and we're able to decarbonize holistically. Okay, so I'll go over the scope 1 and scope 2 emissions that we can help eliminate with the ammonia heat pumps, and we can also do CO2 heat pumps. Now, scope 1 emissions, that results from direct emissions from the burning of fossil fuels. The other thing is that with your refrigerant leaks, your refrigerants, if they're not natural refrigerants, that means if they're synthetic refrigerants, those will have a global warming potential tied to them. But for our case scenario, we do not have that. The scope 1 emissions are canceled out and they're zero. So, and that's the case that everyone is grappling with. It's the scope 1 emissions. Now let's go to scope 2 emissions, indirect emissions. Indirect emissions come from purchased electricity. Now, there's one thing that a lot of you may not know is that natural refrigerants, they have thermodynamic properties tied to the natural refrigerant that make it very efficient to be used for heat pumps. Therefore, your heat pumps uses less electricity to run, and therefore there is less emissions that run from your heat pump. Secondly, we can always integrate renewables into the picture to get you to a zero carbon-free energy source. So this is a slide of efficiency ratings compared to your heating technology. And you can see the one to the right is your natural refrigerant heat pump. The one to the right here is your natural refrigerant heat pump. And then you have electric heating over here to the left. That's between 99% and 100%. You have the condensing oil boiler to the left of that, and then you have your conventional oil boiler to the left of that. Now, with natural refrigerant heat pumps, you have an efficiency of about 300% to 400%, and therefore you're utilizing less electricity to help run it. You're using about 25 to 30% of electricity to help run it, so therefore it becomes a very efficient clean energy source, especially if you have renewables also that you could integrate into the picture. Now, district heating and cooling. So with district heating and cooling, you have a central heating plant or a central cooling plant that produces the steam, that produces the hot water or the chilled water that runs through the pipes. It runs it through industrial places. It runs it through commercial institutions. It runs it through basically universities and the government locations. And also residences are included into the picture. Now, this concept originated in the 1880s using steam and has gained popularity in Europe. And the thing is with district heating and cooling, you can utilize a lot of different sources. So at Simcoe, we utilize heat pumps and thermal storage to effectively get you to a clean energy source. So this is a slide on the evolution of district energy. And you can see here there are several generations of, there's 5 generations ever since the 1880s. There has been 5 generations of district energy. Now, there's 3 points I want to bring with these slides. So the first point is a temperature level. You can see that the temperature level started off in the 1880s at below 200 degrees centigrade, and it dropped significantly to more than 100 degrees centigrade by the 2nd generation. And now at the 5th generation, it's between 5 and 35 degrees centigrade, and that's more the ambient temperatures. The second thing I wanted to bring to the slide is that the energy efficiency is increasing. And you notice the energy efficiency increasing with every drop in temperature. So as the temperature is dropping, the energy efficiency is increasing. The third thing I wanted to bring with this slide is between the 4th generation and the 5th generation, we have the 4th generation, which is the most cost optimal solution, because even I thought when I started at Simcoe that the 5th generation was the most optimal solution because it was the 5th generation. But no, that's not true. There's been a Danfoss report that has shown that the 4th generation is the most cost effective. So what are the benefits of district heating and cooling? Well, I'll tell you. So number 1, the boiler, the chiller. Look on the left side, the business as usual system. You have a boiler, you have a chiller, you have a cooling tower, you have pumps and fans on the left side. Now look at the right side. This is a district energy system. You have your central plant here, and you have your sources of energy, like your solar farm here. You have your wind turbine here. You have the lake or the river here that you could use for your source of heat. You have your free cooling system. So you could utilize all these sources and tap into all these sources to heat and cool your building. And therefore, your building doesn't need to have a chiller. It doesn't need to have a boiler. The pumps and fans are all eliminated. So this improves your energy efficiency by at least 50%. The third point is that it reduces your emissions per building significantly. And depending on your carbon sources, depending on your fuel sources that you're using, it reduces your emissions per building significantly. Next is fuel flexibility. You can use anything at any time. You can tap into your solar farms when you have the solar power available. If for at nighttime, you can use possibly your data center. So you can use any of the fuel sources. So this simplifies building operation and maintenance, and it decreases cost significantly. So where would you use district heating and cooling anyways? Well, these district heating and cooling is used in high density areas where there are multi-use customers, such as residential areas, institutional areas, commercial areas, and industrial areas. All of these can use district heating and cooling in high dense areas. And district heating and cooling integrates a wide variety of low carbon energy sources, and you can see the sources listed here, which are integrated into your energy center and then providing your residents, industrial, and commercial clients with energy. Yeah, so the challenges are huge. You can look at the slides a little later. There are integration complexities, load variability due to the heating and cooling demands, space installation requirements that are required for steam heat pumps because you required a second compressor. So the cost of course, capital cost, because you have to look at the lifetime cost to get your why the why the heat pump or the thermal storage makes sense for you. I'm going to leave this slide to you guys to look over, but yes, district energy makes financial sense because math doesn't lie. And I'm going to conclude my slides and show you the last slide. So this is our vision. It's to enable to enable a decarbonized ecosystem where you have your district heating and cooling loops, where you have your sources of energy from the ice rink, from your industries, from your data centers, which could always be used in your universities and your schools. So I hope this provided some insight into district energy, and thank you so much for your time.